The sixth question says, a particle starts with initial velocity 10 meter per second. It covers a distance of 20 meter along a straight line in 2 seconds. So we'll write what is given in the question first. Initial velocity with which the particle moves is 10 meter per second. The distance covered by it is, I'll represent it with the symbol S, 20 meter, and it took t as 2 seconds. Time taken is 2 seconds. What is the acceleration of the particle? So here we are simply consider the second equation of motion, that is S is equal to ut plus half at square. What is the distance covered? 20. Initial velocity is 10. Time taken is 2 seconds plus half a t square, right? So it is 20 is equal to 20 plus a cancels and you're left with 2a. What about the acceleration here? 2a is equal to 0 and hence acceleration is 0 meter per second square. The correct option here is A. Option A, 0 meter per second square. A particle returns to the starting point after 10 seconds. If the rate of change of velocity during the motion is constant in magnitude, then its location after 7 seconds will be same as that after. So according to the given question, we will draw the simple diagram. For a better understanding, let us say this is the initial position and the object has started moving, reached the point B, say, and it took 10 seconds to go from A to B and to move from B to A. How much of time did it take? It took 10 seconds for its entire journey. It is given that rate of change of velocity during the motion is constant. Rate of change of velocity is constant. What do you mean by rate of change of velocity? Which means dv by dt being constant. dv by dt is nothing but what? Acceleration. Rate of change of velocity is acceleration, which is nothing but constant here, right? Also we need to understand that there is a symmetrical motion. Since the acceleration being constant, the motion is symmetrical. One thing to note is acceleration constant, motion is symmetrical. We need to find the time at which the displacement after 7 seconds is equal to displacement after some time. So what will be the displacement after 7 seconds? It is marked here in the diagram. So after 1 second the object comes here, after 2 seconds the object may reach here, 3 seconds the object might reach here, after 4 seconds the object can reach here, after 5 seconds it might reach here. Then from there, from B, it is going to return back to A, right? Total time taken is 10 seconds. That means 5 seconds will be the midpoint of the journey. Since the motion being symmetrical, at 5 seconds it will be at B, and at 6 seconds it will cover some distance. After 7 seconds it will cover so many distance. After 8 seconds, 9 seconds, and after 10 seconds, at 0th seconds at 0th second it was at A. When it again came back to A after 10 seconds, then it has reached its destination, right? So they have asked its location after 7 seconds will be same as that after. location after 7 seconds will be equal to, so at 7 seconds, let us say the displacement is so much from here to here. This is the displacement, right? At 7 seconds the displacement from final position is noted, and the same displacement I have to take over here from here to here, that is at 3 seconds. The displacement is again the same. Let us say x meter, and x meters are covered. The displacement was x meter. When the time was equal to 7 seconds, the displacement was x meter. Here there is a symmetry which indicates that the displacement at 7 seconds will be the same as the displacement at 3 seconds. That is why I can write location after 3 seconds will be the same. Hence I can write the time t. The correct option is option C. Let us look into question number 8. I'll read out. The slope of velocity time graph for retarded motion is. What do you mean by retarded motion? The object is about to stop. So here we have a VT graph, that is velocity time graph, and it is told that the body is about to stop, which also means that acceleration is negative. The body is under retardation. How do you plot a VT graph for an object that is under retarded motion? It also means that the velocity of a body is decreasing. So if I take the values for a VT graph, I'll write the values for time as well as for velocity. So notice that the velocity of a body is decreasing, right? As you can see here, the values shows about it. So what should be the nature of the graph? The graph should be pointing vertically downwards. Then you know that the slope of VT graph should give us acceleration. Slope of VT graph represents acceleration, right? So how do you get the acceleration for the above graph? So if I have to find the acceleration over here, then it is 10 minus 12 by 1. Time is 1 second, and it is minus 12 meter per second square. And here also, for these two values of velocity, acceleration is minus 2 meter per second square, and for these two also acceleration is minus 2, and here also acceleration is minus 2. What we have observed, acceleration is being negative. If acceleration is negative, it is clearly understood the body is about to stop, it is under retardation, right? The body is under retarded motion. Then if acceleration is negative, then what happens to the slope? It will also be negative. Clearly, slope of VT graph should be negative. So the options here, you have to choose the proper option, correct option from the given 4 options. Slope of velocity time graph for retarded motion is, the object is about to stop, right? Because of its retarded motion, what will be the slope of velocity time graph? Slope of velocity time graph represents acceleration. Hence, acceleration is negative. The correct option is B. Moving on to the next question. The position of a particle moving along a straight line is given by. So they have given us with the position of the particle. I'll write the equation. x is equal to minus 12 plus 18t plus 9t square. We have to find the velocity. How do you find the velocity if position is given? Velocity is equal to dx by dt. That means we have to differentiate the above expression. I'll write d by dt of 12 plus 18t plus 9t square, or it is d by dt of 12 plus d by dt of 18t plus d by dt of 9t square. Or differentiation of a constant is 0, the first term becomes equal to 0. Differentiation of 18t, here 18 is a constant and differentiation of t becomes 1, and differentiation of 9t square, 9 is a constant, it is 2t. Hence I get 18 plus 18t as velocity. What about the velocity at t equal to 2 seconds? I have to substitute the value of t as 2. 18 plus 18 into 2, which is equal to, so what answer I do get here? It is 18 plus 36, which is equal to 54 meter per second. The correct answer is option C. Moving on to the next question, 10th one. A particle starts from rest and moves with the constant acceleration a. Acceleration of the particle is a and time taken is t. Covers a distance x1. It continues to move with the same acceleration and covers a distance x2 in the next time interval t. Which of the following relations is correct? So we'll draw the relevant diagram for the above question. So the object has started from A, it has reached B, it is moving with the acceleration a. A is the acceleration. How much of time did it take? It took t seconds. Let me say, to move from A to B, it took t seconds. How much of distance did it cover? It is x1 meter. It continues to move with the same acceleration and covers a distance x2 meter. To move from B to C, it took x2 meter and the time taken is t seconds. Which of the following relations is correct, they have asked. So we'll now write the expression for an object to move from A to B. So what do we get? Let us divide it into several steps. Step 1, distance covered in first t seconds. I'll write s is equal to ut plus half at square is the relation used. What is the distance covered in first t seconds? It is x1. I'll write x1 is equal to, tell me what about the initial velocity in this case? It is at rest. The object is at rest, means its initial velocity should be equal to 0. Clearly the first term becomes equal to 0. It is half a t square, right? Since acceleration is taken to be a and time is t square, we have the expression for distance traveled x1. Similarly, I can also write the second equation. This time the second equation will be written for an object to move from A to C. Okay, for moving from A to C, let us say the distance is s. It has to travel a distance of s is equal to, initially the velocity was 0, right? That is why it is half a time taken. What will be the total time to move from A to C now? It is t plus t, which is 2t. Hence, the expression for distance traveled here will be 2at square. What about the distance, total distance? We can write s is equal to x1 plus x2. What about x2? We are going to write the expression for x2 now. x2 is equal to s minus x1. S is equal to 2at square minus half at square. So what I am going to get here is 3 by 2 at square. But here we have noticed that x1 is equal to half at square. Here I will write half at square. So half at square is nothing but x1. x2 is equal to 3 times x1. Hence, which is the correct option among the 4 given options? It is option C. Here we have option C, which is the correct one.